Welcome back to Inclusive Design 24 2019, brought to you in partnership with our gold supporters, Barclays Access and Intopia. Don't forget, you can subscribe to Inclusive Design 24 on YouTube by visiting youtube.com/inclusivedesign24 and hitting that subscribe button. You can follow ID24Conf on Twitter, and if you have questions for Eric, tweet them using the ID24 hashtag, and we'll ask them at the end of the session. And a reminder that ID24 is a respectful community, and we have a code of conduct that's available at inclusivedesign24.org/2019/code of conduct.
Okay, and so next up we've got Eric Bailey, who will be talking about the intersection of performance and accessibility. Over to you, Eric.
Hey, thanks for having me. Good morning, good afternoon, good evening, depending on where you're tuning in from. Figure we can just jump right on in. So let's set the stage here. This is a talk about performance, with performance being the manner in which a mechanism behaves. I was conducting some accessibility auditing last year, which is the process of performing manual and automated checks to see if a website can work with assistive technology. The client was a medical education web app, and it was used to train caregivers, so pretty important. It was built using a single-page application framework, using Google's Material Design Library to build the user interface. When I learned that, I thought, Google made it? Oh, sweet. I don't have to worry as much. So, I fire up VoiceOver, which is macOS's screen reader, and I start testing. And things are going pretty well, and then VoiceOver crashes. I try restarting Safari, I try clearing the cache, I try closing other tabs. Heck, I even try rebooting Metal Chestnut. Same result every time. So I ask my boss what's going on, and he says, oh, it's probably problems with the accessibility tree. And the what now? And before I get more into this, here is a question for you. How do you describe an interface? I'm not saying, tell me what you see or hear after you turn the computer on. I'm saying, how do you speak computer to a computer? One way we can do that is with the accessibility tree. Fundamentally, the accessibility tree is a collection of objects, all the little atomic bits that make up a user interface. People who rely on assistive technology use the accessibility tree to navigate and take action on user interfaces. Without a functioning accessibility tree, there is no way to describe the current state of what an interface is, and consequently, no way for some people to be able to use a computer or a smartphone. So, suffice to say, this is a really important piece of technology. So how do you make an accessibility tree? First, you have to give each individual object in an interface a name. Names are short identifiers used to describe purpose. Then you give it a role. Roles are predefined values that tell someone what they can do to an interface object. For example, a role of button means that someone can press it to activate some predefined action. Then we have properties, which are the attributes of the object. Examples of this are its position in an interface, its state, or interactions that are allowed. For our button, that could mean a toggled state to indicate it being pressed in. Think the play button on a media player. Finally, we have a description, which can provide further information about the object if needed. These accessible objects are then programmatically grouped together to form more complicated interface components. So how do you build these interface components? Let's say an operating system alert dialog. That's a pretty commonplace thing for UI. Starting from the top down, we have a menu bar. That's the anchor that we're going to attach everything to. And then we add a title for the menu bar, unsaved changes, so we know what it's all about and what contents we can expect to find. If you're using a screen reader, titles are really helpful as they save you from having to dig around inside of the component to figure out what it's used for. You might also need to close this dialog window once we learn what it's for, so we include a close button in the menu bar. Then we add the body of the dialog, the place where we can place the bulk of the dialog content. In the dialog's body, there's another title, which asks us if we want to save the changes we made to the thing we're working on. We then add text to the body, which will provide more information about what happens if you choose not to save. Then we add a save button to allow us to commit to saving the changes we made. And an accompanying cancel button as well, in case you don't. And presto, we have a dialog component. How cool is that? Because these collected objects have accessible names and are therefore present in the accessibility tree, we can speak computer to get what we want. I can programmatically say, go to the dialog, then its body, and activate the save button. And it works. Isn't that great? So this all might seem a little pedantic, but please bear with me for a bit. On this screen is a bear from the show Polar Bear Cafe, because I love a good pun. We do have this dialogue component, yes, but there's more to it than just that. Interface components have to have a place to live, and that place is an operating system. Operating systems also include components that allow us to navigate to and access the stuff you store on them. It's also the place where we install and run programs, and all the little doodads and widgets we can't live without. And the browser, which is rapidly becoming an operating system in its own right. And the browser contains the mechanisms we use to access the web. And the web is sort of the Wild West in that you can write more or less whatever you want, and it'll usually work, which is both a blessing and a curse. But regardless of how you write what you write, you can't escape the fact that you have to ultimately create HTML for a browser. That HTML then has its appearance and behavior augmented by both JavaScript and CSS. Again, there's many ways to go about doing this, but they are the other two requisite parts that make up the whole that is a modern website or web app. The HTML markup, augmented by both JavaScript and CSS, creates the document object model, or DOM tree, which is a programming interface for websites. Browsers then read the DOM and all the information contained within it to draw an interface, which is then shown to a user, someone like you. The user can then take actions, which updates the DOM, which in turn updates what is visually rendered, allowing us to make our websites dynamic. And running in parallel is the accessibility tree, which is sampled from the generated DOM. I say sampled because the accessibility tree will use specialized heuristics to only surface things it deems necessary and relevant. Modern versions of the accessibility tree are generated after styles are computed, as certain CSS properties such as CSS display and pseudo element content will affect it. This sampled version of the DOM is then read by various kinds of assistive technology, including but not limited to screen readers. And there's two things I'd like to point out here. First, using a visually rendered interface and assistive technology aren't mutually exclusive things. Not all screen reader users are blind, and many people choose to augment their browsing with devices that rely on the accessibility tree. Secondly, the accessibility tree relies on the user interacting with the DOM to update. The accessibility tree is effectively a read-only technology right now, in that we can't work directly with it, only with what it reports. Another thing you should be aware of is it's more of an accessibility forest than it is an accessibility tree. There are different implementations of the accessibility tree. Each depends on what operating system you're using and what version of said operating system is running. This is due to the different ways companies have built and updated their operating system's underlying code throughout the years. And just so we're clear, the DOM can be a part of the accessibility tree, but the accessibility tree is larger and not limited to just the contents of your browser. Because of this, the accessibility tree is more brittle. It has more to pay attention to, and its technical architecture was developed before this whole internet thing really took off, meaning it didn't anticipate the sheer amount of information we'd be throwing at it. Crashing the accessibility tree and therefore breaking assistive technology support is bad, yes. But a large amount of information present in the DOM means that there is an accompanying large amount of work the accessibility tree needs to do to figure out what's what and report on it, which slows it down. This can create a lack of synchronization between the current state of the page and what is being reported by assistive technology, meaning that a user may not be working with an accurate model of the current screen and may be taking action on interactive components that are no longer present or whose meaning has changed. This can create a confusing experience of activating the wrong control or navigating to the wrong place. So how do we help prevent this? Start with writing semantic HTML. Using things like the button element for buttons instead of aria slapped on a div helps lessen the amount of guesswork the accessibility tree has to do when it runs its heuristics to slot meaningful content into its description of the current state of things. This serves to both speed up its calculation and makes what it reports more reliable. And speaking of semantic HTML, here's the raw living DOM tree of an actual website. In fact, it's the schedule page for ID24. Even a static performant website contains a lot of information a computer has to chew through. Again, utilizing semantic HTML helps to reduce the effort it takes to generate the accessibility tree for sites like this. And unfortunately, using semantic HTML is kind of a rare thing these days, which is partly why I'm here giving this talk. So thanks again to ID24 for keeping their markup both straightforward and semantic. Okay, I think you get the gist of it. The code I just showed you, 5 slides worth, we've only covered about 1/8 of one page. It's worth pointing out that this is a relatively simple page in terms of functionality, and that, again, this is a lot of stuff to process. Keeping that DOM tree example in mind, we now have a simple form. It's a pair of unstyled radio buttons inside of a field set, asking you if you want the chicken or the fish as your meal preference. Here's how that form might be translated into the accessibility tree. We have a field set containing a legend with a label of meal preference, an input that's a type of radio with a name of chicken, and it is checked. Another input is also a type of radio with a name of fish, and then finally a button with a name of save. If we use semantic HTML, the names, roles, and properties are automatically filled in for us without any additional effort. When I was speaking about how semantic HTML slots in, this is a more granular example of what I'm getting at. Here's a more high fidelity example, sample again from the ID24 schedule page. I'm using Firefox's accessibility inspector to dig into a text node. There's a ton more information exposed here, including attributes, states, actions, a child element count, relations, and available actions. All of this information is used by the accessibility tree to help it describe the shape of things to the user. And here's an even more high fidelity example, a raw text dump of the accessibility tree from this same page. This is an example of what the language might look like when we're speaking machine directly to machine. We don't speak machine directly though. Before we had Firefox's accessibility inspector, we had to rely on more specialized tools to be the translators. The Paciello Group's AViewer and Apple's accessibility inspector are the two go-to resources. And you'll still need them if you want to inspect anything other than websites or do some really serious digging. So let's make the abstract immediate. What's going on here and why should you care? With my auditing project, I narrowed the problem down to issues with Material Design's radio inputs. This is how they appear visually. And here's how they appear in code. A wrapping div with an input and another div that wraps radio circles and then a label at the bottom. To make a Material Design radio input, you need 6 HTML elements containing 9 attributes with a DOM depth of 3. You also need 66 CSS selectors containing 141 properties, which weighs in at 10K when minified. You also need 2,374 lines of JavaScript, which weighs in at 30K minified. All that will get us a radio input. But you need more than one radio input to be able to use it properly, and oftentimes there's a few options to select from. Sometimes there's more than just a few options, and sometimes there's even more than that. In the case of my audit, we had a ton of radio inputs conditionally being injected into the page. The point being is all this adds up. Google's Lighthouse project, an open source tool that analyzes your website for performance problems, recommends an optimal website DOM tree has the following: less than 1,500 nodes, a max depth of 32 nodes, and no parent node with more than 60 child nodes. What I'd like to call attention to is the max depth of 32 nodes bit. That might seem like a lot of wiggle room at first, but take a moment to think about the templates of the sites you've worked on. There's the frame set, wrapper divs, landmarks, component wrappers, and if you're doing it right, field sets on your forms. each digging a little bit more inward towards that max depth of 32 count. Another part of accessibility auditing is providing a fix to the problems you uncover. It's tough work, but nobody likes to pay people money to tell them all the things that are wrong, but then offer no solutions. We wound up recommending a radio input pattern that utilized 3 HTML elements. It's a pattern developed by my friend Scott, taken from his excellent A11Y styled form controls project. It's worth saying that Scott puts these patterns through their paces and tests them with an incredibly robust set of assistive technologies. So a nice side benefit is knowing I can recommend them with confidence. Visually, it was completely indistinguishable from the original version. And to compare the two solutions, we have a 50% reduction in HTML elements, and we have cut the DOM depth down by 1/3. There's also a 30% reduction in CSS selectors and properties, resulting in the CSS payload for this pattern being reduced by 90%. We've also completely removed 30K of JavaScript, which is 30K less blocking resource being served. Cobbling up a rough prototype, we were able to create an environment that mimicked the conditions of the site we were auditing, only using the new radio input code. And guess what? It worked. VoiceOver didn't crash. So why is this our problem? Why should we care about the fragility of other people's software? Well, prioritizing developer ergonomics without considering the generated HTML can lead to bad things happening. And regardless of our setup, we tend to pile even more things onto our base experience. Things like ads, analytics, social marketing engagement tools, and development integration utilities. And then there's also the Cold War raging between websites and their users. Here's Facebook splitting a single word into 11 DOM elements to avoid ad blockers. And this graph is generated from the median values of how 1.3 million websites are generated, with JavaScript claiming the majority of the share. This JavaScript majority means that it's much more time spent blocking the browser from performing other actions, including things like interfacing with assistive technology. When we throw out what the browser gives us for free, we oftentimes don't realize that there are very real, very important things we sacrifice in doing so. Here's what Marco Zahi, Mozilla's senior accessibility QA engineer, has to say about all this. Nibbling away at those milliseconds it takes for information to reach assistive technologies when requested. My current task is to reduce the number of accessible objects we create for HTML div elements. This is to reduce the size of the accessibility tree. This reduces the amount of data being transferred across process boundaries. Part of what makes Firefox accessibility slower on Windows since Firefox Quantum is the fact that assistive technologies now no longer have direct access to the original accessible tree of the document. A lot of it needs to be fetched across a process boundary, so the amount of data that needs to be fetched actually matters a lot now. Reducing that by filtering out objects we don't need is a good way to reduce the time it takes for information to reach assistive technologies. This is particularly true in dynamically updating environments like Gmail, Twitter, or Mastodon. My current patch, slated to land early in the Firefox 67 cycle, shaves off about 10 to 20% of the time it takes for certain calls to return. And note that all this optimization is only for one browser, Firefox, and that there are a lot of browsers out there. It's also not all about browsers either. Here's a refreshable Braille display, one of the many other kinds of assistive technology that interfaces with the accessibility tree. So someone should do something. You know, the battle cry of bystanders everywhere. Let's unpack this statement sub and figure out what our available options are. For screen readers, the main ones are JAWS and NVDA, both are Windows screen readers, VoiceOver for macOS and iOS, and TalkBack for Android. These are the big four screen readers you're going to probably hear about, and it's just sort of analogous to Chrome, Safari, Firefox, and Internet Explorer in that there's more screen readers out there, but these cover the main use cases you're most likely to deal with. While not all assistive technology are screen readers, if your site works well with them, chances are it'll work well with other assistive technology. Of them, all but one have an open issue tracker, but half have closed source code. This means that while we can file issues, we aren't really empowered to do much more about it on the assistive technology layer. It's also, completely unrealistic to expect someone to submit and follow issues or code pull requests across all trackers in addition to working a full-time job. Our only other realistic option here is to keep the DOM trees of our sites nice and shallow, and there are actual tangible benefits to doing this. Here's Margot again weighing in on his optimization efforts. Reducing the number of milliseconds it takes for a screen reader to start speaking after a key press from about 140 to 100 here or from 120 to 100 there doesn't matter much as on a fast machine. On a slow machine, that reduction is from about 230 to 250 down to 200 or 190. And let's talk about what slow machines means now. If you are disabled and or underserved, you face significant barriers to entering and staying in the workforce. This means you may have less access to current technology, especially the more expensive, higher quality versions of it. Another factor is some people who rely on assistive technology are reluctant to upgrade it for a very justified fear of breaking the way they use to interact with the world. Slow machines may also not mean an ancient computer. Inexpensive Android smartphones are a common entry point for emerging markets, and with Android comes TalkBack. A slow machine might also come from a place you may not be expecting, by which I mean you might have a state-of-the-art computer and are doing state-of-the-art things on it. This requires a ton of computational resources, which makes fast things slow. With less computational resources to go around, we may have unintended consequences, possibly recreating a situation similar to our too many radio inputs problem. Think Electron apps, desktop programs that are built with web technologies. Accessibility auditing isn't something people normally do out of the goodness of their own heart. It's typically performed after a lawsuit has been levied against an organization. And let me be clear, when you create inaccessible experiences, you are denying people their civil rights. The Americans with Disabilities Act guarantees that people cannot be discriminated against based on their disability conditions, and this extends to both private organizations and the digital space. This is a good thing, as it guarantees protections as more and more of the services necessary to living life go online. You need to work with what you have and not what you hope will be. Part of this means understanding that when we want things to be better, we need to understand that these kinds of changes are really technically complicated under the hood and spread across multiple concerns. On top of that, accessibility fixes are often viewed as unglamorous and deprioritized compared to other features. Don't believe me? Here's the support matrix for the title attribute incorporated into the W3C's HTML spec in 1993. It's 26 years later, and we still have a ton of interoperability problems. I don't mean to bum you out, and I don't expect you to become accessibility experts. However, as people who are interested in more than just the surface level of things, you are all uniquely empowered to affect positive change. What I ask of you is to at least incorporate basic accessibility testing into your workflow. If anything, just check to see if a screen reader crashes. A bad assistive technology experience is better than none at all. Whoa, okay, the slide background is yellow now. This is what we call a great segue. Like I said, I love puns, here's a segue. I'm a designer by trade, and part of that job means coming up with alternate strategies for allowing people to accomplish their goal, because sometimes the most effective solution isn't necessarily the most obvious one. With that in mind, we're going to talk about another definition of performance, which is the ability to actually accomplish something. All these little surgical tweaks and code optimizations don't mean squat if people don't understand how to operate the really fast, really performant thing you gave them. Another aspect of dynamically injecting a ton of radio inputs into a page is that it adds more things for a person to think about. This is called cognitive load, and it's a huge problem. It affects our ability to accomplish tasks, and importantly, our ability to accomplish tasks accurately. Namely, it inhibits our memory, our problem-solving skills, our attention spans, our reading comprehension level, our math comprehension level, and shockingly, our ability to actually understand what we see. It's such an important problem that NASA developed the Task Load Index, an assessment tool to help quantify it. This isn't warm, fuzzy feelings about empathy. This is a serious attempt by a government agency to refine efficiencies and prevent errors across their organization. And one of the most interesting things about the existence of the index is that it's an admission that disability conditions can be conditional. Think about it. When's the last time you were tired, distracted, sick, or learning a new skill? Heck, when's the last time you were drunk? Cognitive load is an important thing to track for building rockets, sure, but it also translates to other complicated things like making and using software. One of the things we can do to lessen cognitive load is to lessen the amount of information someone has to parse at any given moment. For the medical education app, we could have added an additional step into the user flow that asks a high-level segmenting question. It's a little bit more friction, sure, but it's being used strategically as a focused choice to help keep the cognitive load lower. This would help filter down the results you get, which makes it both easier for the person and the browser to parse. The other big picture question we need to ask is all this work even necessary? The most performant page is the one you never have to use, by which I mean how often can we sidestep these issues by using other resources and information made available to us to pre-program the results to anticipate what the user needs. If you're interested in this sort of thing, the 2018 Design and Tech Report is a must-read piece. One of the things it revealed was that surprisingly very few companies conduct qualitative user research, which is the practice of asking people how they'd use a feature and how they feel while they do it. Interesting, I know. You know, that's for companies conducting qualitative user research, that's 12% for early stage startups, 32% for mid-stage startups, and 46% for late stage startups. I'm not a numbers person, but there does seem to be a trend going on here. Another interesting thing is barely any companies conduct qualitative testing for features after they launch them. So we're all just throwing features into the larger, ever-evolving ecosystem that is your product, and not actually checking in to see how it'll affect things after you let it loose. As consumers, we also need to remember that we're only seeing those companies that beat the odds. The market is built on top of the corpses of failed businesses who poured all their cash and all their resources into the wrong features. So the second big ask from this talk is really just repeating the first one. It's one thing to read about something and believe it to be true, but it's another thing entirely to put it out into the world without verifying that it works. The web, and more importantly, the people who use it, are too important not to. Thanks for tuning in. I know I'm ending a little bit early, and thank you to the ID24 team for this opportunity. Also, thank you to MyClearText for the captioning. The slides for this presentation, including references and resources, are available on Noticed, and my contact information is available on my website. If you have any questions, put them on Twitter, or please feel free to reach out one-on-one, and thank you again.
Well, thank you very much, Eric. That was a great talk. David, I think we don't have anything directly on the Twitters at the moment. Is that correct? If you unmute yourself.
Sorry, yeah, Patrick. That's where we've got a lot of quotes and retweets and praise. No questions as of yet.
Yeah, and I'm going to do the classic. It's not a question, more of a statement, Eric. So I'm really sorry. You can give me payback in 2 weeks' time. But I just wanted to echo one of the earlier slides, the frustration about having multiple assistive technologies and the lack of support across the spectrum for even sometimes what we would say, oh, this is just a basic feature. I mean, this hand waves the entire complexity behind the scenes, but I hear a lot of developers always complaining, well, why doesn't NVDA do this? Or why is TalkBack misbehaving? My code is perfectly fine. And even adding to that complexity, it becomes a matrix of, well, in this browser with this assistive technology, it starts, it's not supported fully. And yeah, just basically echoing that, I always see developers getting really annoyed at lack of support of things, and having to explain to them that it's software has bugs, the same way that the same way that CSS, yes, HTML and CSS standardization has come on leaps and bounds over the last 10 years or so. But if you think back to the early days of web design, when everything was still black and white and steam powered, I still remember all the all the different hacks just to get Netscape 4.71 Gold to behave the same way as IE8, and Yeah, I mean it's a perennial problem, but on the other hand, you know, I see the positive on that in that you know, people like ourselves that hopefully have a bit of knowledge will always have some kind of employment. So yeah, positive note there.
Yeah. I mean, to bring it back down, like that's not even talking about like regressions where something that works or used to work now doesn't work after something updates. Like,
Oh, absolutely,
you know,
absolutely.
you think you're on stable ground. You know, kind of your comment on, you know, well, my code works, you know, from developers. That's an interesting thing because like, you know, that's kind of only half the picture where like that starts to kind of get into what I think is kind of the core of inclusive design and kind of accessibility and the blurred lines between the two, where accessibility is maybe checking to see that it actually does get reported in assistive technology, but like the inclusive design mindset is, you know, when you make that kind of statement of like, oh, it works on my machine, or it, you know, it works because I can see it in a Chromium browser on my friend's iPad. And that's an immense statement of privilege, in that you have access to the latest and greatest, and you are able to view it under kind of these certain specific conditions that may not be indicative of everyone else's lived experiences. And so like one thing I'd really kind of like to stress again is just that quick little check, you know, the same way you might install linter and address, you know, little persnickety problems with your JavaScript, or if you have a QA team, just pop open VoiceOver. You know, don't even spin up a Windows virtual machine, because I know that's too much effort for a lot of developers I know. Just see if it works. Just see if it makes sense to you, because you know, while there's that initial little bump in confusion with this kind of new way of interacting, like screen readers make a lot of sense. You know, they read out what you write back to you, and if it sounds weird to you, you know, we both know chances are it'll sound weird to other people using them. And then on top of that, just kind of keep in mind that you know, you work on computers all day, so like making sure that it makes sense to you as a person and not as a developer or a designer who knows, you know, words like, you know, like tree shaking and hot module reloading and pattern and component and all that jargon.
Hydrating the component, or whatever the latest euphemism is.
Yeah.
And absolutely, I mean, this idea of, well, just install and test in the various things, again, you know, showing my age, when I used to have, you know, pretty much my desktop shortcuts where all the different variations of browsers that I had downloaded and installed, some of them from you know, places like eVault, just to make sure that you know, it works in that particular version of IE, or that particular version of Netscape or Mosaic or whatever. So yeah, it's nothing new. It's just a return to that. I don't have to do that nowadays so much for CSS or HTML, unless I want to do the latest cutting edge stuff. But yeah, it's a return to that kind of testing for you know, how does it work in AT. And yeah, it's as you say, it might be confusing initially, but it's certainly part of you know, good practice to make sure. And probably also, I'll just mention one of the kind of tensions that I also often see developers go through is this idea that you know, in WCAG, you know, say a developer says, well, I followed all the recommended things in WCAG, my code is as it should be. It's now not my fault anymore that you know, a particular browser X with ATY has lack of support or a problem. And purely from a normative point of view, I'd have to agree with them that yes, if you're just concerned about, you know, does this pass or fail WCAG, to a certain extent, I mean, there are still mitigating circumstances, but if you're doing everything right, at some point, if the browser or AT are getting it wrong, that's kind of their responsibility. However, having said that, you know, it's good and well for a developer to say that, but the end result is still that actual end users will not be able to use whatever it is you're created. So it's kind of a weird tension, really.
Yeah, I agree completely. And it's also like, you know, this whole spiel is not to just kind of dissuade you from even trying. It's more those AT solutions that do have open issue trackers, if you find these bugs, report them, because they do get addressed, and like the people that work on them do care about them. It's, sometimes it's the organization that makes demands of their time that are put elsewhere. But the more that we can kind of quantify these things, it kind of has the two effects. First, it improves the technology for the people who rely on it, which I think is the most important part. And second, it kind of helps you as a developer to become more integrated into how things actually work, as opposed to reading about it and assuming it just works the way that you think it does, which is good because you get a better appreciation for the technologies that you use and other people will be consuming. And I think it's one of those things where it's getting more familiar with kind of your domain can never hurt. And kind of to your earlier point, like I think things have never been better in terms of the platform and like kind of than they are now in terms of like interoperability, but also kind of like the strength of the platform. I remember, I'm gonna show my age here too, like before you could console log things and you just had to like break apart your JavaScript and figure out where something, how exactly you broke stuff. Which is to say that like we're also with this strength at a really interesting, I think, inflection point where kind of the promise of semantic markup is starting to be really seen again. And I think Stuart's talk started to touch on this, where the web is kind of squirting out into form factors that we never originally intended. And some of that is a little bit of growing pains, yeah, but like, specialized reading modes, Kindles, your gas station pump now probably has a web browser in it. And it's one of those things, like, especially with like voice assistants, where if we can directly communicate meaning and intent via, a markup language, that's something that has a lot of staying power, more so than probably the CSS, because visual changes come and go, more so than JavaScript, I think, in that JavaScript best practices change every 30 seconds. It's exhausting. And so like, I'm really optimistic for where it's going to go. And I'm kind of curious to see how it'll all play out.
And I'm pleased to say we've got a question in on Twitter from Kathleen McMahon. Question for Eric: how can developers view the accessibility tree in various browsers? Are there any tools you can recommend?
Sure. I would say first and foremost, Firefox's Accessibility Inspector is my kind of one-stop shop. Their developer edition, I think both versions have it now, but their developer edition gets you the latest and greatest kind of version of that. And what it lets you do is actually view the accessibility tree the way that you would kind of inspect the regular DOM, something I think a lot of developers are very intimately familiar with, only instead of seeing the markup and the CSS properties, you're instead viewing the accessibility tree's kind of hierarchical tree structure and then kind of the properties of the little nodes that branch off of it. And I think the most recent edition also does some stuff like color contrast checks and like lets you hover over to inspect, which is, if you've had familiarity with some of the previously existing tools, is just borderline magical in the ease of use. I think Firefox has actually been, if you let me kind of talk about my favorite organization, I think Mozilla's been doing a lot of really interesting things with their web inspecting tools. Some of it not accessibility related, but their inclusion of this is kind of directly saying that these concerns are first-class concerns. And so I'm really excited to see it presented as a mainstream tool.
Excellent stuff. And for my own part, I'm more of a Chrome person, so that will now get me my monthly check from my Google friends. And even on the Chrome DevTools side as well, there's very equivalent kind of accessibility node inspection tools present as well. So it's not this one's better than the other. It's more looking at it holistically and saying, well, it's nice that it doesn't require now lots of separate software and separate skills that it just places it right in the same place where a developer would start debugging their CSS or their DOM tree, or the cascade view of their network calls and everything else. So it just kind of normalizes it, in a positive way, and it saves me, I have to say, a lot of time and effort when doing audits of websites, which is part of my day job. That now, if I just want to check quickly, why is this node, how does this node, expose itself to AT, I can kind of save myself the 10 seconds of firing up the screen reader and just basically see, yes, it's actually exposing it correctly, nominally at least, from the dev tools. And I've saved myself 10 seconds, which in the course of a day, counts up to a lot.
Yeah. We've also had good success with instituting kind of accessibility checkers on our code repositories. The big asterisk there is auditing tools only check the code that they know about. So like, you still want to do usability testing with people who use actual assistive technology to verify that like it works across the board. But one of the things it does, to your point, is it tackles a lot of that low-hanging fruit, which is really good in that it helps to educate the developer on best practices for these kinds of things. But it also, I kind of view it as a professional courtesy to accessibility auditors, which is very specialized, very, very specialized knowledge that is very difficult to do, frankly. And it takes all those low-level things that are just kind of tedious to have to identify and document and flag, and it just turns it into something that you'd fix the same way you'd fix like JavaScript linting or like kind of CSS formatting, and just kind of sweeps it away. So it allows a professional auditor to actually tackle the meaty stuff and like really use their time effectively.
Absolutely agree. Right, I think that probably covers the questions we had ourselves and on Twitter. So I'll just take the opportunity to thank you again for your talk, and also for stepping in at kind of a relatively short notice. We had a little bit of a rejiggle of our schedule not so long ago. And for the audience at home, if you like this session, hit that YouTube like button, and don't forget you can subscribe to youtube.com/inclusivedesign24 for any future notifications. A reminder that Inclusive Design 24 is brought to you with thanks to our gold supporters, Barclays Access and Intopia, our silver supporters, Adobe and Siteimprove, and our bronze supporters, Samsung Internet, DQ Systems, and the Posiello Group, and is captioned by MyClearText. Inclusive Design 24 will be back on the hour with Sarah Luthwaite, I hope I pronounced that right, talking about teaching accessibility, 10 messages from research. So until then, thank you very much, and we'll catch you on the hour. Bye-bye.